Welcome to Real-Time Mobile Apps with Elixir and React Native. If you're wondering who I am Gaius. I'm an engineer at a company called MailChimp in Atlanta that does marketing automation. And previously to that, I worked at a company called Luma, where I worked on embedded systems as well as building real-time dashboards using React and Elixir. More interestingly, though, I'm an organizer of the Elixir meetup in Atlanta. It's a group of 20 people. We meet every month, and we build software together. Last week, we worked on some Nerve stuff as well. So it's a really good time to be in Atlanta. So the kind of outline for today's talk will be as follows. First, we'll talk a bit about how the sort of, the application in this context that I'm building works. We'll sort of go through that a little bit. And then we'll discuss a little bit more about what exactly the motivations for real-time mobile apps are. And then quickly we'll move to discuss functional programming as well as reactive programming. We'll talk a bit about React Native and React as well, and then we'll move on to discuss Redux. We'll briefly move through Elixir and Phoenix since this is indeed the Elixir conference. And then lastly, we'll do a sort of conclusionary period where we talk about some of these ideas. So, what's real time? When I discuss real time, I mean something like this, right? This is a real-time mobile app. You think of Slack, think of apps like this where people are interacting, they're doing things, they're moving back and forth. You also think of examples of Google Docs, right? Where you're sort of chatting with people, you're commenting, you're working on things collaboratively, and you're doing things that you expect immediate feedback from. But also an example like this, right? Where you sort of have charts and graphs moving, and you're seeing feedback happen as things occur in the world. These are all examples of real time. But the question obviously is why real time? Like, why does it matter for us to build real-time mobile apps? I think there's sort of three areas. The first is expectation from users. Currently, we have sort of a world in which users expect, for a certain kind of experience. They expect that when they type something or when they're working with their friends on a document, that it happens in real time. Right? It happens as they press a button, something happens in the world, something on the computer screen tells them your changes are indeed taking effect. More importantly, real time in the context of mobile is particularly hard because we have to deliver across both platforms, right? You build an iOS app and you imagine that you need an Android app at the same time. And you need to deliver these experiences across different platforms, the web, mobile, so on and so forth. The sort of last sort of issue we have when it comes to real time, that's sort of a user demand, is that our bosses also have demands, right? We have fixed timelines in which we have to deliver these kinds of experiences. And so we have both demand from users who use our products, but also demand from our business users, people who need these products built. So the obvious question then is, what's hard about this? If real time is indeed this pressing concern, why can't we just do it? Well, one of the challenges as you build things fast and you build things at scale is that you have increasing complexity. And so over the course of time, as you build these real-time mobile apps, you find that your app at some point looks like this, sort of a ball of mud, construed. The way you do real-time is different in different places in your apps, especially on mobile, right? It becomes hard to reason about, well, how does the Android app do a real-time? Does it poll? Does it not poll? How does the iOS app do it? If you have distributed teams, it becomes even more challenging. So with that, let's kind of walk through a demo of a real-time web app and kind of talk about, some of the things that we'll encounter. Let's gather that. So here on my screen, I'm going to pull this out into a separate window so it's easier. Actually, let's leave it there. We have a simple app that we can type my name into, right? We can press enter. We have one room here called German Pies in the list of rooms. And let's say I want to go ahead and add a room. Let's add a room called Osa's Place. And now we have a list of 2 rooms. Pretty trivial, right? However, let's go ahead and enter one of these rooms and let's start typing some things. Hey there. Yep. We can sort of type in messages into this room. We sort of see them happen as we sort of type things in, and we can go back to the list of rooms and see them there. Now, what I wanted to demo to you was that I could pull up an Android app on a simulator right next to this, and then that would then also do the same thing. We could sort of see them mirror. However, there's a bug I just discovered in upstream NPM stuff that we won't talk about, but things are broken in NPM land, and I'll have to debug that later. However, what we could do is pull up an Android simulator very similar to the iOS simulator here, and have the same experience, right? Sort of have them happening both at the same time, and that's pretty nifty because we can run both things on my phone or my computer rather, but on simulators. So with that in mind, let's kind of talk about this is sort of a very simplistic case of an app that we can build on our computers. It's a mobile app. It can be delivered to the App Store. Let's kind of walk through how we get to something like this, and more importantly, how we think about React Native in this case on the mobile platform, and Elixir and Phoenix on the back end to make this happen. So, switch displays for a second. I think this is what we need. The trick with live demos is now you have to get your screens back. Let's see if we can do this. So we want to unmirror or? Yeah. I think we might have lost that tab. See it there. Am I missing something?
How do you get to your when it shows when it drops down a little window?
Which one?
Yeah. Okay. Now let's do this here.
Oh.
Anybody see it? Yeah, right there.
Awesome.
All right.
Thank you. Round of applause for the camera guy. Awesome. So with that demo in mind, let's kind of talk about what are some of the challenges that happen when you take an example like that, straightforward, makes sense, let's go ahead and build it. What happens when, things get crazy and we begin to build at scale? Well, the first thing that happens is you obviously encounter the first case of, well, how do you architect an app like that, right? How do you go ahead and build it so that it makes sense when you build it the first time, but it's scalable for your team to work through as time goes on? Well, the first thing I think you encounter is that you have to sort of choose an architecture, right? You have your clients, and they have servers they have to talk to. How exactly do they go about doing that? And there's sort of several approaches that you can take to doing this. The first, approach is to poll, right? So when you add a new list of rooms, you get a new message, you simply call out to your API from the client's perspective and say, hey, given the new things. The second approach is to use some sort of real-time as a service functionality. Think Pusher, think any of the hosted instances of Socket.io and say, well, I will externalize all of my dependencies when it comes to real-time stuff to them. They'll do it for me. I'll call them, and it will make it happen. The third approach is to sort of implement WebSockets on the client side and implement WebSockets on the server side, right? The typical approach that I think some people are used to if you come from Node or come from a JavaScript background. Now, one of the challenges with choosing one of these approaches is deciding, do you need real time in your app, right? So you're prototyping something, you're building something from scratch, or your boss gives you a demand and say, hey, go build this thing. The first question is, do you need real time, right? Can you suffer some non-real time functionality? Can you, maybe make the user wait for a while you spin and you poll and you ask for something back? Can you even just get away with not implementing that feature? The second is, what is the size of your team, right? I think one of the concerns people sort of have to come up with when building real-time mobile apps is, well, how many Android developers do I have? How many iOS developers do I have? If the answer is 0 or none or less than 1, then probably you should not, build native mobile apps and go hire a team. You should consider what are the possible alternatives to going out and hiring native teams to build these functionalities, or perhaps not even build them at all. The second concern you sort of have to think about is complexity at scale, right? While it's easy to build, an iOS app by just going through and finding a course and doing it, the question is, as your app gets larger, can you maintain that? Do you have the knowledge of iOS? Do you have the large enough team to be able to maintain that application? And if you choose to utilize external tools that allow you to do this, let's say pusher, etc., do you have the capacity to understand how those systems themselves are complex as your app grows? Now, this kind of brings us to maybe another approach we can think about is, well, let's find some new tools. Let's think Phoenix, let's think Socket.io. Let's find some new tools that help us solve these problems. But I think this is where we got to be careful, right? There are existing ways of approaching these things, polling being one of them, not implementing real-time being one of them. And I think these new tools can be quite dangerous. So I caution you when I propose these ideas of using React Native on the front end and then using Phoenix on the back end to be careful, because new tools are indeed very risky. And so with that in mind, let's talk about some new tools. In our case, we'll talk primarily about two new tools, first being functional programming and the second being reactive programming. And the most interesting thing here is that we're thinking about the entire stack, right? So the entire real-time platform, so from the front end to the back end, as being functional and being reactive, not just, let's say, the back end or just the front end. So the first question is, what is functional programming? We're ElixirConf, so I'm hoping everyone here knows what functional programming is. But I think what's interesting here is that there are only two things I care about when it comes to functional programming. And so I'm going to talk about them even though we're at ElixirConf, because I think they matter more when thinking about how you build real-time front ends than perhaps they even do when it comes to the back end. So as you know, functional programming is just all about implementing and building applications using functions, right? But functional programming should be thought more of as a style rather than the programming language sort of dependency, because sometimes you may be in contexts where you don't have a programming language that is functional by nature, and so you can still think about, well, how do I implement these functional ideas here to give me some wins? The key sort of takeaway from functional programming that I think of here is that because we have functions lend themselves to decreased complexity over time. Two questions that matter in the context of mobile apps when it comes to functional programming is, one, what should the screen look like right now? And two, what exactly should the data be in my system at this particular moment? So let's talk about that in the context of two things. First, it will be pure functions and what they mean in our context, and second will be state. So a pure function is simply a function that takes some input and returns some output, as you know. However, a pure function is interesting in the sense that it does not modify the state of the world in any way, or rather it doesn't modify any state outside its scope. More importantly, given the same set of inputs, the pure function should return the same set of outputs. So if you take this example here where you have an impure function that is called square, it does indeed take some input and then does some magic, it updates some stuff in a database. By contrast, the pure function simply takes that input and then returns some output. We could take another example like this where we're doing some counting and we're saying increase count. We're passing in a variable called val that we want to count, and then we're updating some value out in the world called count. So by contrast, if we thought about the pure example of this, it would simply taking that input, return some output without doing any modifications to anything outside its scope. And then we can call that function and then set some variable using over and over. But the key there is that we don't do any of that updating within the context of the function itself. The second thing we're going to talk about when it comes to state, when it comes to functional programming is state. So in our case, when I say state, I mean that sharing is indeed not caring, right? This is the case in which your mom was indeed wrong. She was wrong. She was right about everything else, but this case she was wrong, because sharing is indeed really bad, right? And this is especially true in the UI, especially when building real-time mobile apps on the front end. It's not, it's not uncommon to think about functional programming on the back end, but in the UI it's particularly interesting. So when I say state, it's important to think about, what I mean here is that immutability is key when you think about functional programming. More importantly, you should share nothing between components. You should share nothing between different parts of your application. And more importantly, if you have to share, you should think more generally about how that sharing comes to be. So the takeaways here are that pure functions reduce complexity over time. You should share nothing, and then you should think about your state explicitly. So with that in mind, let's talk about reactive programming. We'll kind of talk about reactive programming, one in the general sense, and then more specifically in the case that we care about. So reactive programming is all about asynchronous data streams, right? But what does that mean in the context of building applications? In this case, we'll talk about them. You talk about reactive programming in two contexts. The first is, how did the screen come to be this way, right? So if I'm looking at the screen right now, how did the screen end up like this? What are the set of events that made the screen appear like this? And on the back end, we'll think about, well, how exactly did my system come to be this way? How did my data come to exist in such a way as it is now? This is important because Flux and Redux, which we talked about before, which are from the sort of front-end ecosystem, rely heavily on reactive programming, although it doesn't appear easily admissible in the first sense. They are heavily influenced by this philosophy, and so it's important for us to understand them. So when I mention asynchronous data stream, I simply mean a stream like this, sort of a sequence of events that happen over time, right? So a stream, one event happens, another one happens. Think of click events as a kind of stream that happens over time. But more interestingly, I think that the second idea that matters the most from reactive programming is this idea of data flow. So thinking about how your data flows across your system. So if think of a case in which you have 3 different systems in your sort of ecosystem. You have 2 systems perhaps on the back end, and then some user interface that is displaying some data. Well, if the user interface needs some data from, let's say, System A makes the call or sends the data over to System B, the user interface eventually gets the data. Something happens on the user interface. Someone presses a button, voila, some magic should happen. However, I think this is a cautionary moment because at this precise moment is where things become really challenging and interesting. Because the choices we make now matter. How do we get the changes from the user interface that just happened, the button click, all the way back to System A to tell it, hey, something has happened? The argument that reactive programming makes is that, one, we should think about how the data flows, how it flows back to System A, and then more importantly, how it flows back to the user interface. And I argue that data flow is really important in real-time apps because when you think about real-time apps as they get bigger and larger, is that the only thing happening is you're having things happen over and over in real time, and so how you keep that all in your head as your team grows larger is especially hard. So one of the primary challenges in the React community that I've found is that thinking about data flow often doesn't happen all the way through because you're a UI engineer and you don't have access to the back end. But I think it's important for your entire team to think about this when prototyping because if you don't do this, you're not really taking advantage of React or React Native or any of the cool front-end stuff because all these libraries assume that you've thought about your data flow in some way. So if we go back to our example before and we sort of think about how the user interface should change, my argument is that we should think about data flow unidirectionally when it comes to building these real-time mobile apps, such that you have things on the back end that are happening, and whenever changes on the front end happened, those events get told to the back end, but the front end doesn't change itself. Rather, it gets some new events that tell it, hey, something has changed. So if you think about that, the events are happening on the front end, and on the back end, we simply push updates back to the front end, and that's how these kind of changes happen. So the takeaways here from reactive programming are, one, you should think about your data flow explicitly, and then when possible, you should only use unidirectional data flow. So the data flows from one place to another, and then any changes get alerted to you by the back end. So with that in mind, let's talk about React Native. I think this is where things might begin to click a bit more. So the first thing to think about when kind of talking about React Native is what exactly it means in the context of building applications. Well, React Native is a JavaScript library for building cross-platform mobile apps. The key there is that it's native, and we'll talk a bit more about what that means in a bit. But these are the folks who are using React Native today. You think of companies like Tesla, Facebook, Instagram. So most of the apps you use today have a great deal of React Native in them. It's built in JavaScript, or it is a JavaScript library, more importantly, which means that a lot of the things we care about in terms of developer friendliness, in terms of modern tooling, i.e. ES6, or using things like Webpack or testing tools like Mocha are available to you because you're in the JavaScript ecosystem. More importantly, it's native, which means that it's different from things like Ionic or other frameworks that claim to be cross-platform, because in this case, it simply takes your JavaScript code and compiles it to native code. Right, so it's just as if you were building a native iOS app or building a native Android app in Java. And that's really cool because it means that if you start your React Native application from day one, and at some point you decide, well, I need to write a native component in iOS, or I finally have money for my startup to go hire an iOS dev or an Android dev, well, they can simply write iOS and Android code within the same application, and it will function as is because React Native is truly native. The second important thing about being native is that you get performance improvements because what you're not doing is running a browser within your application that's rendering your JavaScript. Rather, your JavaScript is being compiled to native code and is running on the device as is. So when we talk about components in the context of React Native, what we're really talking about is what we discussed before, which are pure functions. So components in the context of React Native are just pure functions that take some input and always return the same output giving that same input. Put differently, if you think about a component in React Native as a pure function, what you're saying is I give something some input and it returns to me something that can be rendered to a screen. So in this case, we can see different things like the button, we can see some piece of text, we can see that even the entirety of the layout on the screen are just components. Now, if we look at another example here, we can see an example of a button that takes some input and then returns some output. But in this case, the button receives some props. And props here are simply inputs. And inputs to components in React Native are called props or properties because we can kind of think about them as a bit differently than functions. But I like to think about them as functions because in this case, the inputs eventually produce some output, and given those same inputs, we get the same output. Now, because components are just functions, as I mentioned before, and especially in the context of pure functions, what this means is that we can compose them and build more complex functions. So in our case, we can take different components, like the button component, and we can build a larger component, in this case, an entire class component that contains the button component, right? Because the output of the button component is some text, and the input to this other function is simply the button component, and so we can build larger and larger components based on this. And we can see on the left sort of a rendering of what this looks like when we start interacting with the application. Now, we can also define classes in React Native, and classes are a bit different than component in terms of the fact that you can compose them a bit differently. You can apply life cycles, which we'll discuss in a bit. But I like to think of classes as just bigger collections of components. And what that means is that you can simply build larger and larger components. You can compose other components together and do some magic to bind them together. But the key difference there is that at the end of the day, they still take some input and then return some output. Now, classes, because I mentioned before as they're simply just functions with a bit of magic wrapped around them, the classes all define a render method, and the render method is what defines what their output will be. So in this case, we simply have a render method in our class that all classes have, which is simply the output of the class once all of its life cycles have been done. Now, with that in mind, let's talk about Redux, right? Because Redux is where things get interesting. Because as I mentioned just now, if you think about your React Native components as simply being things that take input and then render something to the screen or give you something that can be rendered to a screen, the question is then how do you do state management, right? How do you say, what is the screen supposed to be right now? As I mentioned before, Flux or Redux are simply architectures that have opinions about how we should manage state in the context of application. Redux in particular helps us answer the question, what is the state of the entire UI, right? So what should the screen look like at this precise moment? So you may say, well, React has some state stuff built in. You might have used React before. But I think that's sort of interesting to think about because it's different to say that React manages state and to say that React is an approach to state management. In our case, I think that we should think about React as being primarily about managing particular UI components rather than being about managing the state of your entire UI. This is important when building real-time apps because as things get bigger and more interestingly, as events begin to happen in your application, it's useful to have one place to manage all of that state rather than within the functions or within the components themselves. So in Redux, there's sort of a couple of things that really matter that we should talk through. The first is how we think about state in the concept of application, and more importantly, how we think about changes over time. So there are sort of 3 or 4 elements I could think about when I explain Redux. I think of them as sort of these 4 stages. The first stage on the far right being the view, right? So the view being the React component, the thing that renders. Then you have a store, which is the global state of your application that is read-only, right? So it can only be modified by functions themselves. And then you think about a reducer, which is the thing that goes ahead and modifies the store or changes the state of the world. And then lastly, you have actions, which are things that get fired. And so when you think about Redux, when you have a view, a native React view, for instance, that just shows some text and a button click happens, in the context of Redux, the opinion we make is that, well, that button click itself is an action, right? It's an event on a data stream. And so we fire an action. That action gets handled by a reducer, which is simply a function that takes some output and then returns a new global state of the world. And then that simply gets saved to the global store. And the store is what gives all of your views their inputs, right? So you think about it as a feedback loop. Things happen in your view, they get propagated back and fire off actions. You have a reducer that handles that particular action and updates your global store, and then all of your views get fed by that global store with some new input. And so that your views themselves never really have to maintain. So if we think about what a store actually looks like when we define one, it's pretty straightforward. So in this case, all we have to do is say create store when you make your application, when you define your application. It is a bit of boilerplate, but once you do create store with some magic, your store is created, and when you create your store, you hand it some reducers, which are the functions that modify that store in some way, and voila, you have a global store that you can now use to feed your inputs. So if we look back at the sort of logging component we looked at where I typed in my name Osa and magic happened, let's kind of revisit how that works and think through that in the context of Redux. So in this case, in our login application, all we're doing here is simply say, go ahead and take this login component and we're going to have some value here, and that value is going to be the value of whatever is in the input component, right? So when I'm typing on my screen some input, there should be some value being shown there. The question is, what is the value of the input field at a precise moment? So I'm typing on the screen, or on my phone typing rather, what is the input value at that precise moment? Now, this is a hard question to answer, and I think explains very much how the Redux ecosystem forces us to think. In our case, the key difference here is we think about the input as being handled or being generated by some event, right? So you press something on your screen, an event happens, and that says, well, hey, the username has changed in this context. And so we then have some function defined that we've defined before called this.username changed. That function is responsible for going ahead and changing the state of the world in some way. It does not itself know how to do that, so it then has to call some prop or some property and say, hey, please update the username because the username has changed. It does not itself know how to do that because remember, UI components, in this case a React component, should not know how to do any complex magic. So rather what it does is it fires an action. So it calls an action called this.username changed. And what we do here in this function is go ahead and, excuse me for a second. If we revisit this, what we did when we initially created the login form component is we went ahead and we defined the login form. And what we can do when we actually export the login form is we can connect it to the global Redux store. And what we'll do here in this case is we'll say, go ahead and take that global Redux store and take an action called username changed and attach it to this component I've just created. And so we have a function called username change, and we're passing username change, the function, from our actions, and we're passing it as a function to login form so the login form can use it as a property. So the question is, what does this username change function do that I mentioned in our actions? So it's pretty simple. It simply dispatches some event, and the event type is called username changed, and the payload is the text of whatever is currently in the input field. That action is then handled by a reducer, in this case a reducer called username changed, that simply takes the username that we just passed in and sets it to the global store as before. And so now in our global store, we have some new input being stored as the current username in that input field. So if we go back to that same login form, we can now say that the value of the current input, what should be showing on the screen, should instead be this.props.username. But again, that begs the question, how did we get this.props.username? How did we get that input? In this case, we actually do that by using some magic in React Native, and particularly Redux, called map state to props, that just takes some properties from the global store and then maps it down to your component, so that your component now can have access to the global store all without needing to keep that within itself. And so all we're doing here is say, well, take whatever is stored in the global store within in the username field and give it to me as an input property so that I can use it to display my input field. And voila, we now have the input being shown. And so the key takeaway here is that we have unidirectional data flow. You're typing something in, it sends an event to a global store, that global store gives you some new value, and then you can display that without yourself needing to maintain that. Which means that anyone now in the application that has access to the global store, any other component, can simply say, hey, what should the username be right now, because I need that data to display some information. So we're kind of jumping now to Elixir and Phoenix. We're going to kind of hop over the Phoenix, Elixir introduction because I think that stuff is not as interesting in the context of real-time mobile apps. I think what is interesting, though, are Phoenix channels. If you're familiar with them, Phoenix channels are an abstraction of WebSockets that gives you the ability to do routing, things like presence, but also more importantly, they're cross-platform, which means that you can use the same libraries on the back end, use a front-end equivalent for that, so that in your JavaScript, you can connect to that channel, that WebSocket, and you can do interesting things like join channels and route over the WebSockets. In our case, what we want to do is say, we want to define a WebSocket or a user socket in this case in our application. A lot of this is boilerplate and that comes for free for you, but the only thing that's interesting in our case is that we want to define a room channel that says this is the channel we care about, and we want to give it a wildcard. So any person who joins the rooms star will simply get routed to the room channel. We'll then define a connect function that simply takes a user, and then we'll do some assigning of that user to the current WebSocket. So now let's take a deeper look at this sort of room channel. But first of all, let's go back to our React Native application and see what it looks like for us to connect from React Native to a Phoenix WebSocket on the back end. Well, it's quite straightforward. We have a button press, right? Someone puts their name in, they type their name in, and we now need them to connect to the WebSocket when they press the login button as before. And so what we do is we take that login, we handle that login in some way. We have a function called handle or onButton press, and it calls some action called join socket. The question is, what is join socket? Join socket is another action similar to username changed that we get from the actions and we attach to the login form. And so in our case, join socket is simply an action, and it takes some URL and it connects and creates a new socket. And once it creates that socket, we can go ahead and connect to that socket. And here we're using just the Phoenix JavaScript library that you can get from NPM that ships with Phoenix itself. Once we join that socket and we open that socket, we can then do some stuff. Well, now the socket's open, what do I want to do with it? In my case, I want to fire an action which says, hey, I've connected successfully to a socket, and the payload should be the socket itself. What this allows us to do is take that socket we just created, fire an action that says, hey, one was created successfully, and then store that socket somewhere so that every other part of the UI can use the same WebSocket. Once we've done that, we'll fire an action, as I mentioned before, and then we'll handle that action in a new reducer. All the reducer does is say, hey, take that socket, now store it in the global store so that everyone else can use it. And then we'll do something called actions.main, which just says, take this person that has now joined the socket to the main part of the application, which is that list of rooms. The interesting thing there is once the person comes to that main part of the application, we do some magic. In our case, all we do is we say join the room lobby, and the room lobby is the sort of main part of the application that we want people to see. So we'll call the join room function, again using the socket and username. We'll call a join room function for my actions. The join room function, again, is very similar to the other ones we have, but in this case calls socket.channel, which creates a new channel. And the channel in this case is going to be whatever room name, in this case the lobby. On the back end, once someone joins, we'll go ahead and send them a list of rooms. So this is how we were able to show a list of rooms, and once we create them, get that list back. So we'll publish a list of rooms, and on the front end, what we'll do is go ahead and handle that list of rooms and store that again in the global store, which now means that every other part of the application can also use that list of rooms. So after this, there's sort of two things we can do. Well, we now have a list of rooms. We now have a user on the WebSocket. Things we can do now are, let's say, add rooms, add messages, or handle these kinds of things, but they all proceed along the same path. So in conclusion, you can think about this as sort of the way you build large applications with React Native and Elixir, is you kind of define a paradigm, which is things move from the front end as actions and get fired, and then on the back end, you get messages pushed to you. And it's pretty straightforward to set up an application like this, and you can then begin to build increasing complexity on top of it. So quickly, thanks to my employer, MailChimp, who doesn't use Elixir but allowed me to come here and speak. And thanks to all of you for listening. And if you have any questions, I think now's the time. Thank you. I think he has a mic for you.
So with the unidirectional data flow, if there's an event happening on the front end, a click or something, and you want to wait to render any changes until the server's gotten it, processed it, and passed it back, do you ever have problems with that taking too long and wanting to speed that up, short circuit that at all?
Yeah, so I think that's where things get interesting, right? I think what's useful is to think about two things. The first is, how do you handle that if your API is slow? Like if you're making a web request, if you're making a GET request and it's taking a bunch of time, what you do is you load a spinner, right? It's a typical approach. I think that's kind of the first safe approach, is just do something, block UI until you get that. But I think the second thing to think about then is, well, how can I do optimistic UI updates, right? How do I do something in the UI to give the user immediate feedback, right? That, hey, things are happening or things are going correctly. And then once I get a response back from the server, make some changes. But I think that's where things get hard. But I think the first kind of line of defense is, well, just block UI, render a spinner, the same way you would when building other kinds of applications. Cool. Any other questions? Awesome. Thank you.